Okay. Ooh, hello. Thanks, everyone. So I'm Declan Fox. I run Linea at Consensus. For those who don't know, Consensus is also the company behind MetaMask, Infura, and Hyperledger Besu. We've been building Ethereum infrastructure for over a decade. So today, I want to talk about the most important question facing Ethereum right now. Can we capture institutional finance? Not in theory, but in production with real money. So the title of this talk, Public Chains, Private Guarantees, that tension is exactly where the opportunity lives. Okay, so let's start with what's actually happening. Ethereum settled $14.3 trillion in stablecoins last year, which is more than MasterCard's $7.8 trillion. BlackRock Biddle hit $2.9 billion in tokenized treasuries across 9 chains. Total tokenized real-world assets are somewhere between 19 and 24 billion, up 380% from 2022. And 60% of the Fortune 500 now have active blockchain initiatives. So the debate about whether institutions come on chain, that's over. The only question left is which infrastructure do they choose? And that answer is going to determine the value of every asset in this ecosystem for the next decade. Okay, why is this happening now? 4 things all happening at once. So we have first, regulation finally crystallized. MiCA is enforced across EU. We have the Genius Act signed in the US. So for the first time, institutions have a clear legal path for doing things on chain. Second, the permission chain story is falling apart. You have R3, which pivoted to Solana. IBM abandoned Fabric. The vendors who promised private chains for enterprises have all either pivoted or are dying. Third, institutions want settlement that works around the clock. T+0 atomic finality, repo, delivery versus payment, intraday collateral, all atomic, all programmable. And fourth, the enterprise L2 stack has caught up. ZK proving, zero knowledge proving, works in production right now. Privacy and compliance are built natively into L2 infrastructure. For the first time, public chains can actually meet what institutions need. Okay, this is a real quote from one of the world's largest custodians that told us this directly. They want to replace 60 to 70 internal systems with a single on-chain ledger per asset class. And I think this quote really captures the scale of what we're talking about here. This isn't just about tokenizing a bond so you can put out a press release. This is about replacing the actual core infrastructure of capital markets. And for 5 years, enterprises were told, privacy or Ethereum. Pick one, okay? And honestly, that was true. The enterprise tooling wasn't there, so institutions, they would build on private chains. Canton exists because of that gap. But the architecture is caught up, and now the choice is different. So there are really 3 visions competing for this. Canton is somewhat ahead in terms of incumbency. DTCC co-chairs their foundation. Goldman Sachs and NASDAQ are members. They're doing 280 billion daily in US Treasury repo. And honestly, their privacy model is pretty strong. But you do pay for it. Right? They have DAML lock-in, no Ethereum settlement, no access to public liquidity. And then you have Solana. Okay, so Solana is fast. Visa chose them. R3 is bridging Corda assets over to Solana. But you've still got 92% single client dependency, no native privacy, and a monolithic architecture that can't independently configure privacy and performance. And then you have Ethereum L2s. They're still the largest developer ecosystem in crypto with the EVM, so over 30,000 monthly active developers, battle-tested L1 settlement, modular, open source. The gap there has always been enterprise tooling, and that gap is closing fast. So what do institutions actually need? Not what we think they need, but what they tell us in the room today. We spend a lot of time with custodians, centralized securities depositories, who are tokenizing hundreds of billions in commercial paper, correspondent banking networks. What they want is they want privacy by default. When you have CSDs that run multi-party settlement. Participants should not be able to see each other's positions. That's just table stakes. They want 24/7 atomic finality, and it needs to be cryptographic, not probabilistic. They want open standards, because a lot of these institutions invested, millions in Corda, and then R3 pivoted on them, and they're not going to make that same mistake again. And then at procurement, the number one objection that we hear is, will you be around in 5 years, right? They want longevity. They also want developer talent. They want quantum readiness, and they also want interoperability between private ledgers. So nobody delivers all of this today, and that's the gap. So here's the thesis. L2s are the only architecture that can deliver all three. Privacy, interoperability, and security. Private chains sacrifice trustless interop. Public L1s today sacrifice privacy. L2s can actually resolve that trilemma in a way that's expedient. And now I'll show you on how that looks in an architectural level. Okay, so just a quick primer for those less familiar with ZK or zero knowledge. Zero knowledge proof lets you prove a computation was correct without revealing the underlying data. ZK gives you mathematical certainty with no trusted party and no data disclosure at all. Why do institutions care? Because you can prove compliance without exposing positions. You can verify a counterparty executed correctly without seeing their book. You can coordinate across ledgers without sharing state. And regulators can verify correctness without ever touching the raw data. So that's the primitive that makes this whole architecture possible. How it works. So on the left, you have private execution. So transactions run inside a permissioned Hyperledger Bezu cluster with role-based access control and policy enforcement. Only authorized participants can see the data. The sequencer, or block builder, enforces compliance before a block is even produced. In the middle, you have ZK proving pipeline. So a prover takes the execution trace and generates a cryptographic proof that everything was executed or computed correctly and without revealing any of the underlying data. Now you have 128-bit quantum safe security, and that's not on the roadmap, that's there today, live. And on the right-hand side, you have a proof that settles on Ethereum L1, and over $400 billion in economic security backing it up. So what you end up with is the privacy of a permissioned chain, the settlement security of Ethereum, and the verifiability of zero-knowledge cryptography. So that's what public chains private guarantees actually means in practice. It's an architecture, not just a sort of slogan. If you can compare that to, say, Canton, for example, where settlement relies on their CSP trust model, and Solana, where it's validated consensus, this is backed by mathematics and Ethereum's economic security. So for a regulated institution, that's a completely different risk profile. Now, private interoperability. I'd argue this is the single highest value use case in capital markets right now. So today, when two CSDs need to coordinate, say, settling a cross-border securities transfer, they use bilateral APIs. Okay, each side keeps their own records. When something goes wrong, and it does, you get polling, timeouts, manual intervention. The actual post-trade reconciliation alone costs the industry between $5 and $10 billion per year. Okay, whereas the proof-backed architecture changes this completely. Each participant keeps their own private ledger, and so when settlement happens, a ZK proof confirms everything was done correctly, and that proof gets shared through a common proving layer. Okay, so both sides get cryptographic evidence instead of a promise. And this is the part I really want to land, is that this is not a shared database. Okay, that's what the permission chain sort of vendors promised back in 2018, 2019, but it failed because nobody wants their competitors to kind of see the state. So what we're talking about here is really just a network of private ledgers connected via proofs. And only the proofs cross boundaries, not the raw data itself. So you get delivery versus payment can become atomic. Both legs complete or neither does. And you get to go from a I trust your API response to a I can mathematically verify your execution. And then what about compliance? So compliance here is layered, not bolted on after the fact. Role-based access control sits at the sequencer level, so compliance gets checked before a block is even produced. Privacy is configurable at multiple levels. Who holds what token, who transacted with whom, where does data live jurisdictionally. All of that can be configurable per asset class. And then on the privacy roadmap, what we have today is a role-based access control plus sort of Validium, but next you can have zero-knowledge selective disclosure, so you can prove compliance without revealing transaction data or details. Longer term, we can even use tools like fully homomorphic encryption for encrypted computation on chain. And then each stage builds on the last without having to re-platform. And then what about decentralization? So decentralization can also happen in phases. You could start with a single sequencer, and you can be in production in under 90 days. You can then move to a multi-validator QBFT, where the member institutions can actually run their own nodes. And then full decentralization can happen over time. For multi-jurisdiction deployments as well, you can run dedicated sequencers per jurisdiction with native L2 to L2 interoperability between them. Shared proof aggregation as well can make sure you keep costs sublinear as you scale. And on quantum resistance as well, the ZK proving I described earlier can be 128-bit quantum safe with an algorithm agility built in, so you can evolve as post-quantum standards mature. Okay, and then what about the execution client? So this is something that most people don't think about, but it matters a lot when you're making a 10-year infrastructure decision. So most sort of technology stacks today run a forked execution client. And Ethereum itself has accelerated, actually hard forks now every 6 months. So Pectra, Fusaka, Glamsterdam, with many more to come. And every time that happens, every fork has to be manually reintegrated, reintegrate those changes, which can take up to 12, even 24 months, we've seen. So whereas on our technology stack, we run the mainline Bezu client. We don't fork it, we build it, we maintain it. So when Ethereum upgrades, we're already there. Now on the prover side, in particular the RISC-V piece, this is where it gets really interesting. So our prover is moving to RISC-V, which is an open instruction set. What that means is that we can prove any program compiled to RISC-V, including Bezu itself as a guest program, and that means including Ethereum L1 blocks. So we have the same proving infrastructure for layer 2 execution and L1 state transitions. Why does that even matter? Well, institutional L2s can now natively verify L1 state, which means you get trustless bridges, you get native rollup integration, you get full chain cryptographic verification. And no other technology stack can really do this today because no one else is sort of running the mainline Ethereum client. Okay, so the full enterprise, there you go. The full enterprise L2 stack. So I won't read every line here. You can see the stack on the screen. But the thing I want you to take away is that every component here is built in-house by one team. So execution, proving, identity, the gateway. This isn't assembled from a bunch of ecosystem projects, And the gateway as well is worth calling out specifically because it does the ISO 20022 translation, which bridges the Swift messaging system and on-chain settlement. So that's what actually makes this kind of real for banks in production. Deployment as well is flexible. You can have an L2, you can have a Validium, you can have an L3. It can be managed, it can be self-hosted. But what's important is you get one team, one stack, deployed however you need it. Okay, so some use cases here, and these aren't hypothetical. These are like driving real procurement decisions today. I'll just highlight 3. So tokenized securities. One European CSD alone is looking to tokenize $300 billion euros in commercial paper. You have cross-CSD settlement, which reflects the architecture I just shared, and correspondent banking as well. So cross-border payments where each bank only sees the transactions that they're actually involved in. And all the other stable coins, collateral management, and custody as well. They're all sort of active conversations that need the architecture I've been describing. I think this table kind of speaks for itself. I think Canton is sort of ahead on privacy today. Solana's winning on speed. Ethereum L2 is winning pretty much everything else, and the privacy gap is closing fast. So when it comes to enterprises making 10-year infrastructure decisions, they're not just optimizing for raw throughput, they're optimizing for ecosystem, for vendor lock-in, for settlement guarantees, and on those dimensions, L2s win. Okay, so in terms of the upgrade path, right, like here's the insight that kind of makes this land. A lot of the world's largest financial institutions already run Bezu today, like 80%. So they've already invested in EVM contracts, they've already invested and trained their teams, they've already built out operational processes around this. So they don't actually need to re-platform, right? They just need to upgrade. So you can add ZK proving, you can add interoperability, you can add Ethereum settlement. You have the same client and the same contracts, but now you have new capabilities. And so that's not really a migration pitch, it's more of an upgrade pitch. And it kind of meets institutions exactly where they are already. Why should everyone in this room care about it? Because of the flywheel, right? Ethereum is trustware and ETH value accrual. Every enterprise L2 that settles on Ethereum pays gas, which increases block space demand, which strengthens the economic security, and then more value settled basically means a higher cost to corrupt the network, which actually attracts the next institution, and it compounds from there. So the numbers here are staggering. Global securities markets are $120 trillion. Our trustware report, a consensus, models this out in detail, and there's a link there if you want to go and check that out. But I genuinely believe that institutional settlement is the most important growth vector for Ethereum over the next decade. And the window is closing. So let's be direct about the stakes here. If L2s deliver, Ethereum becomes a settlement layer for global finance. That's trillions anchored to L1. And here's what gets me excited is that you actually have DeFi and TradFi end up sharing infrastructure. So imagine a tokenized treasury from a global custodian uses collateral in an Aave pool, in the same atomic transaction. And that world only really exists if we get this right. So yeah, who's building this? We're obviously building this at Consensus with a bunch of other products that we built over the years. It's more than a decade of core infrastructure that we've been building. And now we're taking all of that and we're building the enterprise L2 stack, which is full stack, mainline Besu, quantum safe proving, all hosted in an open source, incredibly neutral way. Because institutions need to make sure that this is open source and neutral enough for them to audit and trust over the long term. Okay, I'm just going to skip through because I know we're over time. Okay, yeah, so just to wrap up, yeah, if you're building in this ecosystem, come find me. If you're on the institutional side evaluating infrastructure, I'd love to have that conversation with you. I'll be around for the rest of the conference, and my email is on the slide if you want to reach out. Thank you very much.
Do you have any questions? Well, thank you.